best electrode is highly dependent on the specific application. There isn't a single electrode that reigns supreme across all welding scenarios. The selection process hinges on several key factors. Firstly, the type of material being welded plays a crucial role. Different materials possess distinct welding characteristics. Certain electrodes are inherently better suited for joining specific materials than others. Secondly, consider the thickness of the material you are working with. The material's thickness dictates the appropriate size and type of electrode required to achieve a sound weld. Thirdly, the welding process being employed is a determining factor. Different welding processes necessitate different types of electrodes to function effectively. Fourthly, the desired weld quality influences electrode selection. The required level of weld quality will determine the type of electrode needed to meet those specifications. Some of the most commonly encountered types of electrodes include stick electrodes, TIG electrodes, and MIG electrodes. Stick electrodes represent the most basic type of electrode. They find application in a wide spectrum of welding tasks. They are relatively inexpensive and straightforward to use. However, it's important to note that they typically produce a less precise weld compared to other electrode types. TIG electrodes are specifically designed for gas tungsten arc welding, also known as GTAW. GTAW is a high-quality welding process that enables the creation of precise and aesthetically pleasing welds. While TIG electrodes tend to be more expensive than stick electrodes, they offer the advantage of producing a superior weld in terms of both appearance and structural integrity. MIG electrodes are employed in metal inert gas welding, also referred to as MIG welding. MIG welding is a semi-automatic process known for its speed and efficiency in producing welds. Although MIG electrodes come at a higher cost than stick electrodes, they deliver a weld of superior quality. Ultimately, the most suitable electrode for a particular welding job is the one that aligns with the specific requirements of the job. The selection should take into account the factors we've discussed, such as material type, material thickness, welding process, and the desired outcome in terms of weld quality and appearance. Understanding these factors and the characteristics of different electrode types empowers one to make informed decisions and achieve successful welding results. Proper electrode selection is paramount for ensuring weld integrity, structural soundness, and overall project success. It's not about finding the best electrode in an absolute sense. It's about identifying the electrode that is best suited for the unique demands of each individual welding task. When considering the type of material, think about its composition and any special properties it may possess. Is it steel, aluminum, stainless steel, or some other alloy? Each material has its own melting point, thermal conductivity, and susceptibility to oxidation or corrosion. The electrode you choose should be compatible with these characteristics to ensure a strong and durable weld. For example, welding aluminum requires an electrode specifically designed for aluminum, as using a steel electrode would result in a weak and unreliable joint. When dealing with varying material thicknesses, it's essential to select an electrode size that can adequately penetrate the joint without causing burn-through or excessive heat input. Thicker materials typically require larger diameter electrodes and higher welding currents. Conversely, thinner materials call for smaller electrodes and lower currents to prevent distortion or damage. The welding process itself plays a significant role in electrode selection. Stick welding, also known as shielded metal arc welding, is a versatile process that can be used with a wide range of materials and electrode types. However, it tends to produce more spatter and slag than other processes. TIG welding, on the other hand, offers greater control and precision, making it ideal for welding thin materials and producing high-quality welds. MIG welding is a faster and more efficient process that is well suited for welding thicker materials and making long, continuous welds. The desired weld quality is another crucial factor to consider. If you need a weld that is visually appealing and free from defects, TIG welding is often the preferred choice. However, if strength and durability are the primary concerns, stick or MIG welding may be more appropriate. The specific application will dictate the level of quality required. For example, a weld on a structural component of a building will need to meet stricter standards than a weld on a decorative piece of furniture. Stick electrodes are known for their portability and versatility. They don't require any external shielding gas, making them ideal for outdoor welding and field repairs. However, they can be more challenging to use than other types of electrodes, as they require more skill and practice to produce consistent welds. TIG electrodes offer exceptional control over the welding process. They allow you to precisely control the heat input and weld bead profile, resulting in clean and accurate welds. TIG welding is often used in aerospace, automotive, and other industries where high-quality welds are essential. MIG electrodes are known for their high deposition rates, which means they can lay down a lot of weld metal in a short amount of time. This makes them ideal for production welding and other applications where speed is important. MIG welding is also relatively easy to learn, making it a popular choice for beginners. In addition to the factors we've already discussed, there are other considerations that can influence electrode selection. These include the welding position, the availability of equipment, and the cost of the electrodes. Welding in different positions, such as overhead or vertical, can require different electrode types and techniques. The availability of welding equipment can also limit your choices. For example, if you only have a stick welder, you won't be able to use TIG or MIG electrodes. The cost of electrodes can vary significantly depending on the type and size. It's important to factor in the cost of electrodes when making your selection, especially if you're working on a large project. To summarize, selecting the best electrode involves careful consideration of multiple factors. There is no one-size-fits-all solution. The ideal electrode will depend on the specific requirements of the welding task at hand. By understanding the characteristics of different electrode types and how they interact with various materials and welding processes, you can make informed decisions and achieve successful welding results every time. Remember to always consult with a qualified welding professional if you have any doubts or questions. They can provide valuable guidance and help you select the best electrode for your specific needs. Safe welding practices are also paramount. Always wear appropriate personal protective equipment, including a welding helmet, gloves, and clothing. Work in a well-ventilated area to avoid inhaling harmful fumes. Follow all safety guidelines and regulations to prevent accidents and injuries. Welding can be a rewarding and fulfilling trade, but it's important to approach it with knowledge, skill, and a commitment to safety. With the right electrode and the right techniques, you can create strong, durable, and aesthetically pleasing welds that will stand the test of time. Furthermore, proper storage and handling of electrodes are essential for maintaining their quality and performance. Electrodes should be stored in a dry environment to prevent moisture absorption, which can lead to poor welding results. Keep electrodes in their original packaging or in a sealed container to protect them from dust, dirt, and other contaminants. When handling electrodes, avoid touching the welding end with your bare hands, as this can transfer oils and other substances that can interfere with the welding process. Use clean gloves or pliers to handle electrodes. Before welding, inspect the electrode for any signs of damage or contamination. Discard any electrodes that are cracked, bent, or covered in rust or other debris. Using damaged or contaminated electrodes can compromise the weld quality and potentially create safety hazards. Maintaining your welding equipment is also crucial for ensuring optimal performance and safety. Regularly inspect your welding machine, cables, and ground clamp for any signs of wear or damage. Replace any worn or damaged parts immediately. Clean your welding equipment regularly to remove dirt, dust, and other debris. A clean machine will run more efficiently and last longer. Calibrate your welding machine periodically to ensure accurate settings. Proper calibration will help you achieve consistent weld quality. Keep your welding area clean and organized. A cluttered workspace can be a safety hazard and can also make it difficult to find the tools and materials you need. By following these best practices for electrode selection, storage, handling, and equipment maintenance, you can maximize your welding skills and produce high-quality welds that meet the demands of any application. Always prioritize safety and consult with experienced professionals when needed to ensure successful and safe welding operations. Welding is a complex process that requires a combination of knowledge, skill, and attention to detail. By continuously learning and improving your welding techniques, you can become a more proficient and confident welder. Welding certifications can demonstrate your expertise and enhance your career opportunities. Consider pursuing welding certifications from reputable organizations such as the American Welding Society. Stay up to date on the latest welding technologies and trends by attending industry events and reading technical publications. Networking with other welders can provide valuable insights and opportunities for collaboration. Welding offers a wide range of career paths from manufacturing and construction to aerospace and automotive. With the right skills and qualifications, you can build a successful and rewarding career in the welding industry. Embrace the challenges and opportunities that welding presents, and you will be well on your way to becoming a master welder. The importance of proper joint preparation before welding cannot be overstated. Cleanliness is paramount. Remove any rust, scale, paint, grease, or other contaminants from the surfaces to be welded. Use a wire brush, grinder, or other appropriate tool to thoroughly clean the joint area. A clean joint will ensure proper fusion and prevent defects such as porosity and inclusions. Fit up is also critical. Ensure that the parts to be welded are properly aligned and fitted together. Use clamps, jigs, or other holding devices to maintain the correct alignment during welding. Improper fit up can lead to distortion, cracking, and other problems. The type of joint design will also influence the welding process and the selection of electrodes. Common joint designs include butt joints, lap joints, T-joints, and corner joints. Each joint design has its own advantages and disadvantages. Choose the joint design that is best suited for the application and the materials being welded. Preheating the base metal can also be beneficial in certain situations. Preheating can help to reduce the risk of cracking, especially when welding thick materials or high-strength alloys. Preheating also helps to improve the fusion and penetration of the weld. The appropriate preheating temperature will depend on the type of material, the thickness of the material, and the welding process being used. Post-weld heat treatment may also be necessary to relieve stress and improve the mechanical properties of the weld. Post-weld heat treatment involves heating the welded part to a specific temperature and then cooling it slowly. This process can help to reduce the risk of cracking and improve the toughness and ductility of the weld. The appropriate post-weld heat treatment cycle will depend on the type of material and the application. Proper welding technique is essential for producing high-quality welds. Maintain a consistent arc length and travel speed. Use the correct welding parameters such as voltage, amperage, and wire feed speed. Overlapping passes can help to ensure complete fusion and prevent undercuts. Avoid excessive weaving, as this can lead to distortion and cracking. Clean the weld after each pass to remove slag and spatter. Inspect the weld visually for any signs of defects. If defects are found, repair them immediately. Document your welding procedures and results. This information can be helpful for future reference and for troubleshooting any problems that may arise. By following these best practices for joint preparation, welding technique, and documentation, you can consistently produce high-quality welds that meet the demands of any application. Welding is a skill that requires continuous learning and improvement. Never stop learning and striving to become a better welder.